Oh yeah, well,
€50.
is it?
Yeah.
How much?
30.
30. I'm talking about.
No. I kind of like the idea of a giant.
Giant pizza.
Well, I cannot eat that.
If you finish it.
They don't have halal, but they can put different toppings on different parts, right?
Yes, exactly.
So you could have like
Vegetarian kind of pot.
yeah.
But have
No
not
pepperoni.
to cut that part.
What?
You can ask them to cut that half off.
No.
Why?
Don't cut that part.
Why?
Because they use the same color in the meat and the whole thing.
I see.
Yeah.
And they could use another pot that you can be there watching them to do it.
No, like,
It's
you
just
don't
fine.
No, I understand what he's saying. Yeah, don't ask him to slice it
Yeah.
because they'll use the same slicer. Well,
No,
you
that's
think,
why I said that you use a different slicer.
That's why,
Yeah.
like, we can also.
that's what he's saying. Yeah.
16 is 32 inches, so we can have two pizzas.
But I kind of like the idea of having a turkey pizza.
Like the last time it was as big as the chicken.
You got one?
Yeah.
With who?
Someone's birthday.
Oh, birthday. See, when in my life am I going to sit down with a turkey and pizza? It doesn't happen too often.
If you go there, if you eat it, if they can give you, if you eat it, if you finish it, they give you free. You don't pay for it.
I know, I heard that. But that's one person.
Yeah, it's one person.
And one sitting.
In one sitting, in like 30 minutes as well.
No.
No.
I know there's a time limit.
No.
No.
Are you sure?
Yeah, no.
Are you sure? Oh well, then I think this sounds like a challenge. Well, we could always just go for a vegetarian pizza for the whole thing.
No way.
You want your pepperoni?
Yes,
Is it?
I do.
Right. Well, anyways, look, we'll work something out.
And this is cheaper, like €5.
But I just really like the idea of a 30-inch pizza.
Can you get the aerial picture?
That's
You could actually. We'll have to convert inches into centimeters. We'll do that.
You
We'll
can
do that
have,
later.
like different taste and it's good.
Yeah. Okay. We'll figure something out. Anyways. But
The restaurant barbecue tonight?
which restaurant?
The restaurant barbecue tonight?
Yeah.
You know what I'm talking about?
No. Where is it?
You know the Mace? Mace.
Yes, I know Mace. Okay. There's a good restaurant there.
Yeah, it's the pizza, literally good.
Oh, I think I know the place you're talking about.
Do they have 30 inches?
Yeah, no, 16.
But their pizza is better.
Look, we'll talk about
Pizza is
tomorrow.
better, the taste is better than the
Yeah, the taste is better. But the taste
See, the taste or the size? Taste. Perfect.
quantity and quality.
Quality. Good quality.
We'll think about it tonight and it's planned tomorrow then. But first I need to see if the principal will give me any money for it. Otherwise we're paying for it ourselves.
Or
Right.
you can contribute, it's not you can even be buying it.
Give €5 each. I think that's okay.
Yeah.
I think I can live with that.
B2.
Two, thank you. Alright, now, can you get the light there, KJ? So, remember I asked you to write down the information from earlier. Right, so, you have it there,
1.1.
Taken right here. This force is
ACB. Oh,
No,
100
100.5 G, and then there's a force here. I'm going to redraw that a bit nicer.
My
Okay?
paper was easy.
Was pretty easy, yeah. 100.5 G.
But the real paper will be easy.
Don't know. We'll dot a line across here. We'll dot a line across here. And then this one here. That's an OR, and we'll dot this line across here. Now look, guys, when I did this question, I wanted to use the three-force theorem. Now I regret doing that.
Why?
Well, I don't know if I made it easier. Do you think I made it easier by doing this?
I don't know.
No. So I think what would have been better would have to just do turning forces, clockwise, anti-clockwise. But then the problem with that is you have to resolve the four vectors along the ladder, which I didn't like.
But last time you did the same thing with the, like, two forces.
But yeah, but this you have the question open. This is a 4 force. So I had to combine two of them to make it a 3 force. In any event, right, let's pop down the info. So, what was this height here, Tekken? 1. And this height here?
0.1393.
4,
39.
3, 9. And then the hypotenuse, well, we can know it, but 1.1. And how long is the ladder altogether? 4.5, wasn't it? So this will be 3.4 for this piece, yeah? Now we know this angle, don't we?
Yeah.
So that means we know this angle. It's the same. That's 90. We really want this angle here or this angle here. I would love if I knew this angle. Oh, but I can know this angle because I can know this angle. Right, so give me a calculator. I'll get my calculator. Okay, so if I type in tan inverse 1 over 0.439, can you see that this angle here, oh, I knew this already, this angle here is 66, which means this angle here is 90 minus 66. Yeah, 23. And then this angle here is 180 minus the last angle. So this angle here is 156.3. Perfect. Now I can get this angle by using the sine rule. I'll call this angle x here, okay? Sine x over 1 equals, oh, now I need to know this angle. Oh wait, I'm going crazy. Sorry, I should use the cosine rule. We don't. So we'll use the cosine rule. I'll call the whole thing L. I really regret doing the question this way, by the way. Just FYI, if I did this again, I wouldn't do it this way. L squared equals 1.1 squared. What's wrong? That's fine, yeah. Plus 3.4 squared minus twice 1.1, 3.4 costs 156.3. Right, 1.1 squared plus 3.4 squared minus twice 1.1, 3.4 costs the angle, square root the answer. So this length here is 4.43 in total from here to here. So now I can use my sine rule. Sine x over 1.1 equals sine 156.3 over 4.43. So the x is 5.7. So that means what's the total angle here now? I have to add it to, what was it, 66.42. So now our situation is we have an S, we have an OR. This one here though is OR cos 72.1. This one here is OR sine 72.1, and there's also a weight going down of 100.5 G. So you can say this equals this. The up equals the down. And I get OR is 1036 newtons. So now I can resolve it finally. This will be 1036 cos 72.1, and then the other one will be 1036 sine 72.1. What's the answer? Make me happy, KJ, and tell me that this is the answer for part 1 and 2. What is it? The other one?
96.
And what's the other one?
986.
So that's definitely right. And the other one is what?
326.
326. Ah, close enough, right? Right?
How did you get the R again? Okay, you need to post it.
Whatever. I'm hungry and I want to continue. Can I close this?
Yes, please.
I did this, by the way, again, I say I did this question stupidly. Don't do it this way. Let this be a lesson of how not to do this question. If you're wondering, well, that's great, Stephen, thanks for telling me that now. How should I have done it? What you should have done, but I thought my way would be quicker, is you have an S here, you have a vertical, you have a horizontal, you have this here, and you have this here. But the problem is, you have to say, take this as a turning point. This will be clockwise, 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 anti-clockwise. So you have a clockwise plus clockwise equals anti-clockwise. You have an up equals down, and you have a left equals right. And you produce 3 equations to solve. But the only problem here is you would need to work out all these distances, this distance and this distance, which isn't horrendously bad because it's just the costs of the length on the ladder. Anyways, if this comes up, well, no, it won't actually. Okay, let's move on with our life. Right, what's the next one like?